In this video, we're going to go through a short activity to show the difference between simple interest and compound interest and just kind of give you an idea of how the formulas work and compare. Then there's some practice problems to do after, and I will show you the answers to those, but not do all of them. So first of all, we have this investment. If you invest $100 at 20% interest for 1 year, how much interest will you earn? And then we'll see what the ending balance is after 1 year. And then we're going to fill out the chart for 5 years. So on the leftmost column, we have number of years. The principal I started filling in is just going to stay at the $100 each time. We're not adding on to our interest each time. So this interest in the middle column is what we earn in just 1 year. So time is always going to be 1. And then the ending balance is your principal that you put in plus your interest earned. Okay, so we will have in the middle column here for the first year, we've earned $20, just 100 times 20% or 0.2. We get $20. Then add that on, we end up with $120 at the end of the year. Now, when the bank configures or calculates the interest for the following year, they're just going to do the same thing. It'll still be $20, 100 times 0.2, our initial principal invested. But then we left that 120 in there, so we get $20 more. So now it's up to 140. Now for the next year, it'll be the same. I mean, you could fill this out on your own if you want, but $100 here. I is still going to be 100 times 0.2. That doesn't change. That'll be $20. But now we're adding that on to our 140 that we had in there. So now we're up to 160. So you can probably predict every time we're going to have the same interest. So I don't even need to calculate that anymore. I just know what that is. But then we're going to add it on to what we had in there before. So this is our ending balance at the end of 4 years. It'll be the 160 plus 20 equals 180. Now go ahead and pause the video, do the 5th row there. Okay, and I'll fill that in as well. And we get 180 plus $20 is going to be $200. So that is at the end of 5 years. So in general, our formula for interest is I equals PRT. So the interest earned over the whole time, if I were to add all these up, I get $20, $40, $60, $80, $100 total. That's my total interest earned. And if I add that on to what I initially put in, the $100, I get my $200. So there's a couple of different ways we can figure out the ending balance. We can use this formula, I equals principal times rate times time, and we would get the same thing. We would get 100 times the 0.2, but this time we're going to put 5 in for our 5th year. And when we calculate that out, we're going to get the 20 times 5, which would be $100. But that's not our ending balance. Our ending balance has to be added on to that interest, added on to our principal. So P plus I is another form of the formula, and we can write it as A equals P plus I, and the P, the principal start amount was 100 plus the $100 earned. So I'm just using simple numbers here so you can see how it works. So these match up now. You can see here where this 200 ending amount adds up when I use the formula. Now there's different variations of the formula. There's this form here where we can replace the interest with the PRT. So we're doing that like kind of literal equations and kind of manipulating and making some new formulas based on old ones. So we would have amount equals the principal plus interest, but this time I'm going to write interest out as PRT. So that's one form, and if you plugged everything in, you would get the same answer. And then the last form, which is one we kind of use a lot, is it's a little more condensed. I'm going to factor out the P. We haven't done too much factoring in Math and Society, but you've probably seen that before. This P is common to both of those terms, so I can pull it out front. It's kind of like reverse distributing, and then I would have a 1 left there plus RT, and if I were to multiply that back, I would get P times 1 is the P here, P times RT is my PRT. So I'm going to focus on this form and show you how that works. If I plug all my values in, I would have the initial 100, and then I would have my 1 plus the rate, which is 0.2, times my time, which is 5. A equals 100 times, and then I would have my 0.2 times 5 is going to be the 1. So I end up with 1 plus 1 there, which would be 2 times 100 equals 200. So I do get the same answer no matter how I do it. I could plop it here as well. We already figured out the PRT, but I'll just write it again. So all those formulas are the same answer, give the same answer. And which one we choose depends on kind of what we're given, what we're trying to solve for, and things like that. So we'll go through that in the examples. So now if we jump down here and we look at the compound interest, let me just get rid of some of this stuff here out of the way. We want to earn interest on our interest. So it's a little bit better deal. We'll see how much better. This one we're not adding more money in, but the bank is taking our interest and rolling it over into our principal. So that's actually helping us out. So I've done the first couple of rows here, but we are going to use the same formula. We're going to base it on the same type of thing, like just saying this is interest earned in just 1 year, except for when we earn that $20, our new principal becomes 120. We're going to add it on. So it's very similar to what we were doing before, but as you can see here, the first year we get $20 just like before, but our ending balance is 120. So that becomes our new balance that they're going to base the interest off of. So, or base it on. 120 times 0.2 will give us $24. So that's increased a little bit. So now we have 120 plus 24 is 144. So what's happening here is we had our initial 100 plus the 20 from the first year plus the 24 from the second year is what that 144 all equals out to. So now that becomes our new balance, and we can do 144 times the 0.2 because we're just basing it on that 1 year, and go ahead and figure out what that is. And now I get 28.8. So I'm going to go ahead and add that 144 plus 28.8, and I will get 172.8. Now take that value and put it on the line here, 172.8, or you could say 80 for 80 cents. And that becomes our new balance, and follow the same process to continue the last 2 rows. So pause the video and finish that out. Okay, so now we have the answers up here. I'll make it a little bit larger. Sorry, I had to go over the edge a little there. So what I did was just continue on in the same pattern, multiplying the new balance by 0.2. So I have all these factors of 0.2 happening, which shows me that this formula is going to be exponential when I end up figuring that out. And I get 207.36, which then becomes the new balance for the 5th year, adding on $41.47. But notice I don't round until the very end. And I add that on and I get 248.83. So you can see we have 248.83 when we compounded. And the bank added our interest into our new balance. I can help that grow a little bit more compared to the 200 for the simple interest. So here is, so that would be the better deal, the compound. Formula for the compound interest using, without using a chart, because we don't want to have to do that every time. I just want to show you how it's built. But this is similar looking a little bit to the formula over here for simple interest, the A equals P times quantity 1 plus RT, but this one's different. So P sub N means the ending value. The future amount is what it's typically called. So that's very similar to A in the simple interest formula. So you could even replace that with A if you wanted to, but our textbook uses P sub N. And then we have the principal is the same. Sometimes you might see that as P sub 0, the starting amount for the first year, or the 0 time has passed, initial amount. And then we have very similar looking, we have 1 plus the rate, but now it's divided by this value K. We'll have to talk a little bit more about K in the examples as we go. Raised up to the NK. N is the same as T. They just want to use a capital N for this formula because that's a useful subscript instead of T. K is the number of times it's compounded in 1 year. Now, when we did our example, we just did 1 year it was compounded. But imagine if I did this every half year, then I would even be building more because that interest would go in and roll in more and more. And then monthly, daily, it's even better and better. So we're going to use the formula real quick to make sure everything matches up. And then I'm going to do a second video for the practice problems. So I've filled everything in. I have 100 for my principal, 0.2 for my rate, 1 for my number of times compounded in a year. I have 5 up here for my time, which we're calling N in this formula. And then I'm going to go ahead and calculate this exponential. So it would be 1.2 raised to the 5th. We want to follow our order of operations. So we have to do our exponents first. So we're going to do that 1.2 raised to the 5th power. Make sure you're not just multiplying by 5. And I would get 2.48832. Try to keep that on your calculator. And then times by the principal, which is 100. And I get 248.832, which is the same as what I got above, and I just round it to the nearest cent. Thanks for watching. I hope you find that helpful. Have a great day.